Au revoir, you guys. Okay, so we're about to get started on a different type of problem that involves still segments intersecting somewhere in the circle. Okay, but this one's different because this time the angles are created by secant and tangent lines intersecting outside of the circle. So the ones we were just working on, these two intersected inside the circle. This one, they kind of intersected on the circle. So there are slight differences to these problems. So when you guys are solving, you have to think, which situation is it? Are the lines or segments or rays intersecting on the circle, in the circle, or out of the circle? Okay, so you have to decide which case it is so you know which nifty formula to use. So be on the lookout for that when you guys are solving these types of problems, because I will not tell you which formula to use. You just have to look at it and instantly know. Alright, let's get going. So we're going to be using one of, again, the amazing properties I talked about in the Prezi. So let's take a look at the Prezi. Okay, so these are the circles that have angles that are created by secant and tangent lines intersecting outside of the circle. Guys, and the relationship is the measure of an angle formed by a secant and a tangent line that intersect outside the circle is half the measure of the difference of the two intersected arcs, which I interpret that the two intersected arcs as the outer arc minus the inner arc if we're finding our differences. Guys, and there are three cases to this. They all use the same formula though. So if you look at this picture, let's see what's going on. Okay, so what is ray PR? Is that a secant? Is it a tangent? What is that thing? Is it a chord? Well, since this ray slices through the circle and hits it in two spots, bam, bam, that means it's a secant. So ray PR is a secant. Now, what is ray P to the S? What is it? Is it secant, chord, tangent? Well, since this ray hits the circle in exactly one spot, that means it's a tangent line. So this is the case where a secant and tangent line are intersecting the circle. So I'm just going to write that down so we just have that valuable information. So this is when a secant and a tangent line are intersecting the circle, which in this case, the secant we said was P to the R, ray PR, and the tangent was ray PS. Okay, so that is going to look like this right here, where we have a tangent and a secant. Guys, so the relationship is half the measure of the intercepted arc. So if you see here, the angle hits the circle, and the intercepted arcs are the arcs that start and end where this angle starts and ends where it touches the circle. Okay, so whenever we do this, it's half the measure of the intercepted arc subtracted. Okay, and whenever you do this, you start with the arc that's the farthest away from the angle on the outside of the circle. So like between my two intercepted arcs, arc AC and arc DEC, the one that is further away from this angle is angle DEC. So that is the one that you start from. So that's why I called it the outer intercepted arc. So it's the outer intercepted arc minus the inner one, or the one closest to the angle, intercepting outside the circle. So we do the outer arc minus the inner arc and divide by 2. All right, let's get this going. Let's get this going. Let's get this going. Let's go. Okay, so I'm trying to find the value of x in each of our examples. I currently don't have 5 and 6 written down yet, but in all of them, in example 4, 5, and 6, we will be solving for the value of x. Okay, so in this picture, angle P is located at x, so I'm going to be solving basically for angle P. All right, let's get going. Let's get going. So the measure of angle P, which is ultimately x, equals the difference of the two intercepted arcs, and we're going to divide those by 2 after we subtract them. Okay, so it's 1/2 my two intercepted arcs subtracted, which what are the two intercepted arcs in this picture? Which arcs start and end where the angle starts and ends? Do you guys see it? I think you do. Yes, you do. That is correct, you guys. It is arc RS and arc QS right here. Okay, so those are our two intercepted arcs as they start and end where the angle will start and end. So this one starts and ends here. This one starts and ends here. So it's where the angle hits the circle and the arc that kind of like goes through the angle. Okay, so my outermost arc, or the arc that's furthest away from angle X, or P in this case. Okay, which of our arcs RS or QS? Which one is the furthest away, or what I call the outer arc? Which one is the outer arc? It is arc RS. So we're going to do the measure of arc RS minus the inner arc, or the arc closest to the angle, which in this case is QS. So the measure of arc QS. All right, let's fill in our values and solve. Yay! That wasn't so bad, right? Okay, so the measure of angle P, well, P is secretly X, which is what we're trying to solve for because it's find the value of X. So this is X degrees equals 1/2 times my two arcs, which is 174, is R to the S, minus, whoa, sorry guys, my paper slid over. Rude. All right, 174 minus QS, which is 98. All right, let's get to solving, then we'll be done. Okay, so X degrees equals 1/2 of 174 minus 98. Well, again, I like to do mental math if I can, which 174 is much easier to subtract by 100 than 98. So I'm going to subtract it by 100 and then use the difference to finish my answer. So 174 minus 100 is 74, but I should be 2 higher than that since 98 will be 2 less than that. So 174 minus 100 is 74, plus 2 is 76 degrees. Man, oh man, let's get going. All right, and then half of 76 degrees. Okay, well, let's see here. That'd be 38 degrees. Oh man, you guys, and guess what? That's it. So if you recognize one of the pictures, all you gotta do is subtract the outer arc minus the inner arc and divide by 2. And guess what? It'll be the angle created by either the secant or tangent lines that intersect outside the circle. Fun times, you guys. Example 5 and 6 will be just as fun, so get excited. But on those examples, we're going to have slightly different pictures because sometimes we're going to have 2 tangents, sometimes we're going to have 2 secants, and in this case we had 1 secant and 1 tangent, which is pretty exciting. So wait for it. Example 5 and 6 will probably blow your mind. So have fun, you guys.